The first version of the DIY bridge had a different truss design to the refined version, which was analyzed. It was constructed using clips which allowed the trusses to move around freely and led to the bridge collapsing much faster than expected. Furthermore, the bridge deck was made a lot weaker. The bridge had minimal issues carrying a load of around 500 grams or 1 kilogram. However, once a second kilogram was added, the bridge quickly collapsed. Following the failures of its predecessor, the second version of the bridge quickly began construction. This version features a stronger deck as a result of more care taken in reinforcing smaller details. Furthermore, the trusses are now connected with single pieces rather than clip and joint assemblies, removing unwanted freedom of movement in the trusses. Whilst its predecessor featured cross-bracing along the top of the trusses, this new version had to cut costs in order to both keep weight at a minimum and make applying loads easier. Cross-bracing, however, was never strictly necessary, as no horizontal load was applied, but this may have helped support the structural integrity of the build. The length of the bridge is around 685 mm, with a clear span of around 610 mm, a width of about 80 mm, and a weight of around 438 grams. To test the load capacity, jam jars and cans of tuna were used. The jam jars weighed about 510 grams each, and the cans of tuna weighed about 120 grams each. Firstly, 2 jam jars were added, giving a load of about 1,020 grams. The bridge didn't seem to encounter many issues with this load. Following this, cans of tuna were steadily added. After 3 cans of tuna, the load held rose to about 1,380 grams. From there, it was time for the final push. Just as the 4th can of tuna was added, the bridge unexpectedly collapsed. Overall, the bridge has a maximum load capacity of 1,402 grams, which is larger than the load capacity presented previously due to inconsistencies in the weights of the materials used as loads. Overall, the bridge could support around 3 times its weight, making it fairly efficient. The bridge could be improved in a variety of ways. Firstly, having all truss members constructed from fewer, or ideally single pieces, would prevent them from popping out when placed under a demanding load. Further reinforcing of the deck itself would have also gone a long way in ensuring the bridge would not collapse as readily when heavily loaded. Finally, having some form of pre-built support with a few truss members spanning beneath the deck would have helped prevent it from deflecting as easily.